what numbers do we want to see? Go overhead questions about. I see a lot of 3s, I see some 2s, I see some 4s. 1 can kind of be done on decimals if you know what you're looking for, so I'll show that. We'll do 2 and 3s. And 4, and then 5 can really be done on decimals, and I'll show that too. So we'll start with 2. Because this is an equation y equals 3, you have to know what type of slope that would give you. It's just a y equals, it's not y equals mx plus b. So you have to remember your Hoy bucks. So what would your slope be? So m equals 0 should be your answer there. If you put 3, that was incorrect. Change that. Questions on that one? For 3, we're finding the range. So you should start at this point. That should be an endpoint, and it keeps going up. So that would be everything above that point. It would be y is greater than or equal to negative. Questions on those? For 4, you had to find your slope and y-intercept to find the equation. Your y-intercept was at positive 1. Your slope was positive 4 over 3. So what would the equation of that line be? Then I'll show 5 on Desmos and then go back to show 1. Remember that if you do use Desmos, you have to say use Desmos, otherwise I don't know what work you did. What is it? So if you were using Desmos, you could use it to graph, find the y-intercept. You already have the slope and graph those points. You could graph it by intercepts, but your x-intercept is a decimal fraction, so just keep that in mind. And then for number 1, you could use Desmos. If you put in the ordered pairs into separate lines, you could then count your slope on the graph instead of doing it algebraically. So this would be down 1, 2, 3, to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, so negative 1/3 is what that was simplified to be. M equals negative 1/3. Questions on either of those? Okay. So we're going to go through SOL A.2a through C. Some of them I'm going to show you the work for. Some of them I'm going to show you how to do Desmos for. Some of them I'm just going to show you how to do Desmos for because we'll talk about them later. We'll try and do as many as we can before lunch, and then whatever we don't finish, we'll come back and do. So I would say for these problems, you're more than welcome to write down all the work, but you have this recording. You'll be able to go back and write down that work. So don't feel like you have to write that all down right now. You could just write the answer and then go back and do that. because I'll show you how to put it in Desmos and all those things. I will be talking through it, so if you do want to write down the work, you can. So for number 1, I know it's been a while since we did exponent rules, but if we have something on the outside, we are multiplying that number to all the exponents on the inside. So that would make this 2 squared and x to the negative 6. We can figure out what 2 squared is, which is 4. Multiply this 4 and this 4 together to get 16. And if we're multiplying like bases, we are adding, or in this case subtracting, their exponents together. And our final answer cannot have a negative exponent, so you would bring it down. So the final answer for that one was 16 over x to the 10th. For number 2, you're now dividing, so you can actually divide the numbers 15 and 3 to get 5. You're dividing like bases, so you're going to subtract the exponents. So that would be negative 5 minus 2 and 7 minus negative 8. Once you figure out what those are, negative 7 and 15, you can't have a negative exponent in the final answer, so we would bring that down. So then the final answer for that one was 5y to the 15th all over x to the 7th. For 3, because you have parentheses, you need to do your order of operations. Do what's inside the parentheses first. So you're dividing like bases, subtract those exponents, 3 minus negative 2 and 4 minus negative 4 to get 5 and 8. All of that is still being raised to the negative 1, so we would multiply both of those by negative 1. And then we can't have negatives in our final answer, so both of those would get brought down. 1 over x to the 5th, y to the 8th. And then for 4, we have stuff inside the parentheses, but we can't do anything with that. We do have exponent and exponent. So we would apply that to both things inside the parentheses, multiply those exponents, figure out what 2 to the 4th would be, which is 16. And then when multiplying your y to the 3rd and y to the 4th, add those exponents. So 16y to the 7th would be your final answer for that one. Before we talk through 5 through 7, what questions do we have on those 4? Nature.
For all the exponents, we keep the ones that were previously called on the top, and we can also put them on.
If it was already on the top. So if you don't see a fraction, it's technically already in the numerator because it's over 1. But if it was positive and in the bottom, it would just stay there. For 5, it's kind of similar to 3. Do what's inside the parentheses first. Divide your 30 and 6 to get 5. Subtract your exponents, 5 minus 3, to get 2. And then raise everything to the second power. So we have 5 squared x to the 4th, and then figure out what 5 squared is. So 25x to the 4th was that final answer. For 6, we have to remember that anything to the 0 power is 1, so that whole numerator becomes 1. In our denominator, the only thing we have to do is change the y to the negative 3. It was a negative, but it's already in the denominator, so we flip it up. So y to the 3rd all over 6x to the 4th was your final answer for that one. And then 7, you have to multiply the exponents in your numerator and denominator. Then subtract your exponents since you're dividing. So 6 minus negative 5, and that will give you a to the 11th. Questions on those 3? So I'm going to show you how to do 8, and then we'll go back. I'm going to show you how to do these in Desmos, or how to check this off, or remind you how to check this off. So I put in the original, but instead of lowercase x's, I capitalize them. There's a reason for that. And then I put in our final answer. It'll ask you, do you want to do a slider? If you add the slider and change what that is, these two numbers should be the same, which they are, so that's how we know that answer is correct. Then in the second one, there was a second variable that x already has a slider, so we just need to add the slider for y, change the number, and these two numbers should be the same, which they are, so we know that's the right answer. The x and y are already there, so we just need to make sure they're the same answer, which they are. Same thing for 4 and 5 and 6. 7's a little different because it has A's. So A, B, C, D, F, G. There are certain variables that you can use lowercase. You could also use uppercase, it doesn't matter. But X and Y you have to capitalize. So if you added the slider for A, changed it, those should also be the same. For 8, you can put in the original, put in all your answer choices and see which one matches. And the last one would be that one. So D, I think, was that answer. So the work is up there, but you can also check yourself in Desmos. Questions on how we check that in Desmos or questions on this page? On the next page, I'm going to have you write down these answers, and then we'll go over Desmos when we get back. So 9x minus 5, 10, 2x plus 2, 11, 3x minus 5, 12, 7x plus 5, 11 or those, I'll go back. 13x minus 3, 14, 3x plus 1, 15, 4n plus 1, and 16 was C. So, as I mentioned before, this is not something we've covered yet, but we will. But for now, as a way to solve this in Desmos, I'm going to show you that. So if you type in the original problem, it's going to give you a line. Whatever that line is your answer. So, and you should be able to read the line, but this says y-intercept at -5, slope of 1, so x minus 5. So whatever the line says, that is your answer. Same with this one. Type in the equation, 2x plus 2. The parentheses way we'll talk about later. Same thing with 11. Y-intercept at -5, slope is 3, so 3x minus 5. Same thing with 12. Y-intercept was at -3, slope is 1, so x minus 3. And then same thing with 14. The slope here was 4. 3, so 3x plus 1. 15 had ends, and if you type in ends, it won't graph it for you, so you have to change this to x's, but then it'll still do the same thing. And that one was 4x plus 1. 16 was a little different because it was multiple choice. So if you were to type in the original, it'll still give you that line. If you put in all the answer choices, you can see which of those lines overlap the one that's already there. So the black line was your original, the orange overlaps it, so that would be your answer. Questions on how we do those in Desmos or those answers? Then for 2C, you can circle these three answers that I'm going to show you on Desmos, and we'll come back and talk about 18. So some of these can be done in Desmos, some of them can't be. It depends on the problem. So for 17, your answers were 2, 2x minus 3, and 2x plus 3. So before you start writing down 18, I'm going to show you how you would do that in Desmos. So you type in the original. There's a lot of things going on. So this is the original, the thicker lines in red. And then I typed in every single answer except for the 2 that was there. Anything, if you start off with an x squared, your answer is not going to be x squared. So we can get rid of those. Those are just there to confuse you. And then of the ones left, we're looking for which of these lines go through the red at the x-axis. So the blue and the black lines are the only ones that do that. So those would be 2 of your answers. So you could find those using Desmos. The other one is something you would have to know how to find. So when we get into factoring, we'll talk about how these can both be divided by 2, which is why that is also a factor. Okay. Questions on that one? 18 is something you would have to know, so you can go ahead and write those down. I'll talk through them. So the factors for part A are x minus 1 in parentheses and x minus 3. The x and y intercepts you should be able to find where it crosses the x-axis and y-axis. So at 1, 0, 3, 0 for your x, and then 0, 3 for your y. Domain and range you should also be able to find. Some of the notation is going to look a little weird, but we'll talk about that later. But you should know these. So the domain would be all real numbers. The range is everything greater than or equal to -1. And then you can write down these 3 answers for 19 through 21, A, C, D. And I'll show you how to do those 3 on Desmos. If you need me to go back to 18 or any of these, I will do that after I show you these ones. So kind of the same thing that we were just doing. If I put in the original and put in all the answer choices, I'm looking for which one crosses the black line at the x-axis. So the red one would be your answer. 2x plus 5. Same thing for 20. I'm looking for where do the lines cross the black line at the x-axis. There is another one, but it's like way off. It's like way down here. So the one that would be your answer is the green one, x plus 6. And then same thing for 21, except the format is different. So you would put in each of those it tells you your zeros or intercepts are at 2 and 6. So if you wanted to plot those two and look for which of these go through those 2 points, there's only one. The green one doesn't at all. The blue goes through one but not the other. And the red goes through one but not the other. So the purple goes through both. Questions on any of those? Anyone need me to go back to any of the problems so you can write down answers? Anyone else need me to go back to any others? Okay. This is already in Canvas, but I'm going to let you know as well. The next one that will be due next Friday is A3. A3 has a lot, that's why it's just one. We have done A3. You can still use Desmos to see if you can get those done. Make sure you are trying these. It is for your benefit. The SOL will be here before you know it. I don't know when exactly, except that all SOLs are between May 12th and the 20th. So it will be here soon. Then everyone should have these notes in front of them. My plan is to go through the definitions and steps, go through 5 questions, any you guys want to see, and then you'll have time to practice. So you can start writing down the definition and the steps. While you're writing, I'll just read that off. So substitution method is a method of solving systems of equations by substituting equations within one another. So as we start to do this, it may seem familiar to you because we kind of did this before. So you will solve one equation for x or y, substitute that expression into the other equation and solve for the variable. Substitute your answer into one of the original equations and then solve for the other variable. So it's a lot of solving, substituting, solving, substituting, solving. Matthew, are you writing this down? Close it. I think this has a letter. So this and the next 2 sections are calculators, so feel free to use that. Anyone else still writing? So let's try this first example. So we first have to look and see, are either of these equations solved for x or for y? and in this case, it's a rare case, that yes, they're both solved for y. So when that's the case, you can take the first expression, this, and put it into the second y, or you can take the second expression and put it into the first y. It doesn't matter, because they're both equal to y, so you can set them equal to each other. It's going to look something like 4x minus 1 equals 2x minus 5. You took one equation and you substituted it into the other. And this is something we've done before. How would we solve this? Victoria. Okay. And remember that you can do this one at a time or do things simultaneously. So if we added 1, we'd have to subtract 2x. We have 2x equals negative 4. And divide both sides by 2. That's only part of it though, because we only solve for x. We still have to solve for y. So you're going to take this value and put it into one of these, not both, but either or, doesn't matter. So where x is, you're going to put this value in and solve for y. Let's say I chose the first one. I would put in negative 2 and begin to solve for y. So we get negative 8 minus 1. So our y value would be 1. And then the last thing we need to do is write these two things as an ordered pair, because we just found a solution. So our answer would then be negative 2, negative 3. Before we go to the next one, what questions do we have there? For the second set of, the second system, are one of these equations solved for x or y? Yes. The first one. As long as one of them is, we don't have to do the work to find one. So then we're going to take this expression, what y equals, and put it in for y in the second equation. If the arrows and the circles, all that stuff helps you do that, you don't have to do that. So then we would rewrite the second equation, 2x plus 3 times 6x in parentheses equals negative 20. And then you would keep going and solve. So we get 2x plus 18x equals negative 20. What would we do next? Combine your like terms. And then divide 20 on both sides. So x equals negative 1. Then take that negative 1 and put it back in your equation. As we did for the first one, you could put it into either one, but since the first one's already solved for y, I would use that one. That would be my go-to. If you put it into this one, you'll just have to solve a little bit more. It'll be a little bit more work. So what's our y value? Nature? Negative 6. Negative 6. Or is it x equals negative 1? So then how would we write our answer?
this has bled in. I have a little one. Okay. Maybe. I can get it.
Same process for 3. This one is solve for y. Where would I put x plus 9? Which word?
Will you put the x with the dx in the 5?
So this is set equal to y. So all of this has to go together. Where would it go? Anyone?
Will you replace the y with the x?
So it would be 3x plus 8, then in parentheses, x plus 9. It's like the same thing we did for 2, but the expression is a little longer. And then you would start to solve. You have 3x plus 8x plus 72 equals -5. Combine your like terms. We have 11x plus 72 equals -5. What would be our next step? 11x equals -77, and divide both sides by 11. Then we would take that x and put it where? Cameron.
Can I just read
Sure.
y equals -7?
So we're putting it back in that first one. You can put it in either, but the first one will probably be the easiest. So what's our y value? Alex, 2. So then what's our order of care? Alex, 7. What questions do we have so far? For number 4, do we have an equation that solves for x or y? So it's different this time. We have an equation, but it's not solved for x. That's okay. The process is going to be very similar, except now because this is x equals, we're going to put it in for x now. So when we rewrite this second one, it'll be 2 times 4y plus 7 minus 6y equals 12. So the biggest thing about these is making sure that you solve for the right variable and put it in for the right variable. If you put it in for the wrong variable, you'll end up with 2 variables still, and that's not what you should have. So 8y plus 14 minus 6y equals 12. Combine your like terms. Get rid of 14 by subtracting it to the other side. And then divide both sides by 2. Then where would we put -1? question?
I'm running forward.
In front of 4?
Like in for y.
For y, okay. So x equals 4 times negative 1 plus 7. What would your x value be? So then our order pair would be what? So even though we found x second, we would still put that first. Do you have any questions so far about this process? I'm going to do one more on the back. So for number 5, do we have an x or a y that's solved already? So we have to solve for 1. Really, you have the choice to solve for whatever you want, but depending on what you solve for, you may end up with fractions and then have to substitute in fractions, so just be careful with that. If you want to avoid that, I would say look for the variable that has 1 or negative 1 as a coefficient. That'll be the easiest way to go. So if we had to solve this one for y, what would we do? How would we get y by itself? And whether you put it in the same order or you flip it, doesn't matter. So then we have an equation that's solved for y, and the process is the same. We would take this and put it into the y of the second equation. So 5x plus 3 times negative 2x minus 2 equals negative 8. Then distribute and solve. Minus 6x minus 6 equals negative 8. Combine your like terms to get negative 8. And add 6. Negative x equals negative 2. And divide both sides by negative 1. Put that value back in for x, and you have multiple choices again. You can put it in either of the original ones. You have to solve a little bit. Or you can put it in the one that's solved for you. I would do that one. It'll be less work. So then what would your y value be? If we multiply those two and subtract 2, what would we get for y? So I will say, of the remaining questions left, I think there is at least one that's a no solution, and I think at least one that's an infinitely many. When you go to solve that, or substitute it and solve it, when you combine your like terms, they're going to cancel. You'll realize real soon that it's no solution or infinitely many. So of the remaining ones left, are there any we want to see, go over? If you want me to find which one is the no solution or infinitely many, we could do one of those.
Yes, let me figure out which one that is. I think. I think it's 7, but I'm not 100% on that. So let's try 7. If it doesn't work for you.
Okay. So for this one, we would be solving for this x. It's the one that had the coefficient of 1. So get x by itself by doing what? X equals 4 minus 5y, or if you want to switch it, you can do that. And then we would be putting this in for x in the second one. So 3 times 4 minus 5y plus 15y equals -1. Distribute. And when we combine our like terms, they're going to disappear. They're going to cancel. Is this a true statement? Does 12 equal -1? No. So what type of solution is that? It's not 1 because we don't have variables. Think about your types of solutions. Which one would that be? Say it louder, please. So when your variables cancel, you're either going to have no solution or infinite no. Other questions before I let you practice? So you could be working on the following things: the rest of problems from these notes, the Khan Academy that's due next week, so you can get it out the way. Khan Academy that's due this week, if you haven't finished or done that. If you finish both of those things, you could be working on SOL A.2a-c for next week. Let me know